Whenever you get this, make sure you remember that that is the domain. That can be helpful later down the road. So the first thing we're going to do is we're going to take our derivative to get our f prime to do the first derivative test. So we get a negative sine x plus 1/2. Alright, so then we set this thing equal to 0 and we solve. Actually, wait a second. I should have a 1/2 right there. Okay, that equals 0. Now what we can do is we can move that 1/2 to the other side, so then we have negative sine x equals negative 1/2. Let's see, we'll make those both positive because we can say we divided both sides by negative 1. So what values of x would give us a positive 1/2? Think back to trig, and sine is only positive where the y values are positive. So that's everywhere above the x-axis. So what are the angles in this interval right here that will give you 1/2 for sine? And that would be right here at pi over 6, and right here at, actually it should look about the same, but oh well, I'm just rough sketching it. And that would be 5 pi over 6. So our two answers here, our two critical points, are 5 pi over 6 and pi over 6. Alright, let's create our sine line graph. We have pi over 6 and 5 pi over 6. Alright, let's do our signs. Let's pick a 0 here. Remember, we have to stay within this domain, but 0, since it is bracketed there, we can check it. So plug 0 in, and let's also plug in, let's do pi over 2. And what I was just thinking about was what angle is between pi over 6 and 5 pi over 6, and right in the middle we have pi over 2. And then let's also try something after 5 pi over 6, which would be pi. And let's plug those bad boys in. And remember, we're plugging them into f prime because we're trying to find out what the slope is for this, so that we know if it's increasing or decreasing. So we know that f is increasing or decreasing. Alright, so we plug in 0. Let's see, we plug in 0 right here, we get 0, and then we add 1/2, so we get positive. If I plug in pi over 2, this would be a negative 1, because sine of pi over 2 is negative 1. Well, it's actually 1, but because of that negative sign right there, it's going to be a negative 1. Negative 1 plus positive 1/2 will still be negative. And then for pi, let's see, if we plug pi in, this would be 0 again. Sine of pi would be way over here, be negative 1 comma 0. And since the y value is 0, the value of sine would be 0, and negative doesn't even matter. We have plus a 1/2, so we get a positive. So we have positive, negative, positive. Alright, next let's do our double derivative. Alright, so we do our second derivative. We get negative cosine x, and now the 1/2 is gone. Alright, where does that equal 0 in our domain, the interval that we're given from 0 to pi? Let's see. That's kind of still looking at this. Cosine is only 0 at pi over 2, so negative right here doesn't matter. We divide both sides by negative 1 and it goes away, but our only answer is going to be pi over 2. Alright, so we do another sine line graph. We have pi over 2 right here, and we got to pick a number before pi over 2 and a number after pi over 2. If we pick a number before pi over 2, that would be in this region. So we would pick a number right here, and that would give you a positive cosine, no matter which number you pick. You can pick a number, just make sure it's not lower than 0, but I don't need to. I know they're all going to be positive. But then because it is negative, it's going to make the concavity be down, so it's a negative. Conversely, on the other side of pi over 2, all of those values would give us a negative cosine. And a negative times a negative would be a positive, so we have a positive on this side. Alright, we got a really good, a lot of information here that we can do our graph. Nothing's tricky. Go ahead and put our dotted lines where they need to be. They need to be at 5 pi over 6 and pi over 6. Because we're in pi's, I'm going to make my tick marks. Let's see, I'm going to have a pi over 2 right here, and this will be my pi. I'm going to split pi up into 6 parts since we have a denominator of 6 for our critical points. So that means this would be pi over 3. I'm sorry, pi over 6. This would be 2 pi over 6. This would be 3 pi over 6, but then simplifies to pi over 2. Let's see, pi over, I already got pi over 6, and I need to put a dotted line right there. And then we have, that would be 4 pi over 6, then 5 pi over 6, and then 6 pi over 6. Yeah, I'm going to write that out for you guys really quick. We got pi over 6, and 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. So I'm not lined up, but I just wanted to write all these out so you guys can see them. 3 pi over 6 will simplify down to pi over 2, and 6 pi over 6 will simplify down to pi. Alrighty, now we got another critical point at 5 pi over 6, so I'm going to draw another dotted line right here. And then we also have that inflection point right here at pi over 2. Alright, let's get graphing here. Now, in order to draw our curves, remember our curves there's 4 different types. The increasing ones, so this one's increasing, and so is that one. And we have our decreasing ones. We have this one and this one. So we have all these 4 curves. But in order to draw these curves, we must start at a point. We have to have a point to start at. So 0 is usually the easiest one to plug in to get a starting point. So if I plug 0 up into this guy, let's see, we get cosine of 0, which is 1. And that would be 0, because 1/2 times 0 is 0. So we just have a 1. Let's make this one right here a 1. So make that 1. And we'll make this down here -1. Alright, so the first thing that we do, we got to do our double signs. Let's do that. Before, remember, we don't have to graph anything below 0 because that's not in the domain that they gave us. The problem gives us. So before pi over 6 we have a positive, and since pi over 6 would be over here, it would be concave down. So we have, is it positive? Oh yeah, it's positive. So we're going to increase, and we're concave down. So I'm increasing, concaving down, and then as soon as I hit pi over 6, we're going to start decreasing, and then we're still concaving down. So we're decreasing, still concaving down, and then as soon as I hit that purple line, I'm supposed to change my concavity. How do we know? Because that purple line represents pi over 2, and the concavity then goes to positive. But we're still decreasing. So decreasing, decreasing, decreasing. Then once we hit our next orange line, that's when we change from decreasing to increasing. So now I'm increasing and still concaving up. Oh, I went a little bit far. I'm supposed to stop right at pi. But there you have it. There's our cute little graph, and we're done.